Hey champs of Examsnet, welcome to the question series of Examsnet. Student, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find so many entrance exam question papers along with their detailed PDF solution. And you must download our app. The link is available in the description box for the better preparation of your exams. So today, students, we will be solving VITEEE 2022 question paper. In this particular video, I'll be solving the physics part of the paper. So starting with the very first question of the physics series, that is question number 1. The root mean square speed of smoke particles of mass 5 into 10 to the power minus 17 kg in their Brownian motion in air at NTP is approximately. Okay, so first of all, this question is from the chapter of kinetic theory of gases. Kinetic theory of gases. So we know that the VRMS speed, root mean square speed, is given by under root 3 kbt by m, where kb is the Boltzmann constant, and its value is given by 1.38 into 10 to the power minus 23 joule per Kelvin. Okay, so just put the numerical values in this under root and we will get our desired answer. It will be equals to under root of 3 into kb is 1.38 into 10 to the power minus 23, and temperature, it is at NTP, so the temperature will be 293 over mass is given as 5 into 10 to the power minus 17 kg. Okay, so solving it, we get vrms is equals to 15 millimeter per second. Okay, so from these four option C, that is 15 millimeter per second, is the correct answer. Yeah. Okay, so moving on towards the next question 2. The equation of a particle executing simple harmonic motion is given by x equals to sine pi t plus 1 by 3m. At t equals to 1 second, the speed of the particle will be. Okay, so we have to find basically the speed of the particle. So this question is from the chapter of oscillations. So we are given the equation of simple harmonic motion, that is x equals to sine pi t plus 1 by 3m. Okay. So at t equals to 1 second, this equation will become x equals to sine 1 plus 1 by 3. So it will be equals to, x will be equals to sine 4 pi by 3, which is equals to minus of under root 3 by 2. Okay. So for speed, v will be equals to omega under root of a square minus x square. We all know this basic formula for this. So putting the values, omega will be equals to pi. Since omega is, we know that it is equals to 2 pi f. Na f is what? And 1 over time. So for this, omega will be equals to 2 pi over 1 by t time. And if we are assuming time to be 1 second, so omega will be equals to 2 pi. Okay, so here write 2 pi under root of a square minus x square. So a is 1 at t equals to 1 second. Okay, so it will be 1 square minus 3 by 4. Root 3 by 2 will become 3 by 4. So solving it, we get v is equals to pi by 2 meter per second. Basically it will be equals to pi is what? 3.14. So putting its value 3.14 divided by 2. So it will be 157 centimeter per second. Okay. So among these four options, the option B, that is 157 centimeter per second, is the correct answer. Now, next question 3. Following our expression for four plain simple harmonic waves. Okay. So the pair of waves which will produce destructive interference and stationary waves respectively in a medium R. Okay, so we have to find the correct answer among these A, B, C, D. So this question is again from the chapter of oscillations. So in case of destructive interference, we know that the phase difference phi is what? 180 degree, or we can say pi. So the wave pair 1, that is y1 equals to a cos 2 pi and 1t plus x over lambda 1. And the second one, that is y2 equals to a cos 2 pi n1t plus x over lambda 1 plus pi, will produce destructive interference, and stationary or standing waves will produce by equations third and fourth. That is y3 equals to a cos 2 pi n2t plus x over lambda by 2, sorry, lambda 2, and y4 equals to a cos 2 pi n2t minus x over lambda 2. Okay, as the two waves traveling along the same line but in opposite directions. So the destructive will be produced by the first and second, and the stationary waves are produced by the third one and fourth one. So among these four, option D, that is first, second for the destructive, and third, fourth for the stationary wave is the correct answer. Now, next question 4. If a charge Q is placed at the center of a closed hemispherical non-conducting surface, the total flux passing through the flat surface would be. Okay, so this question is from the chapter of electrostatics. Electrostatics, okay. So we are given a closed hemispherical surface, and here it is charge Q. So we have to find the flux. Okay, from the Gauss law, we know that the flux through any closed surface is equals to 1 over epsilon naught times the total charge enclosed by the surface. So the total flux through complete spherical surface, if we considered a full spherical surface, for this the flux will be phi equals to q over epsilon naught. And since we are considering only half part of this sphere, that is the hemispherical part, so for this it will be 1 by 2 half of the sphere now. So the flux will be for this hemispherical surface, the flux will be 1 by 2 q over epsilon naught. That is option B is the correct answer, 1 by 2 q over epsilon naught. Okay. Uh, it is the non-conducting surface. Okay, if a charge q is placed at the center of a non-conducting, yeah, the correct answer is 1 by 2 q over epsilon naught. If the, for example, if the case is for the conducting sphere, na, so for conducting sphere, whether it is conducting or it is a spherical shell or it is a hollow sphere, for these three conditions, the charge always resides on the surface of the sphere, not on inside the sphere. For that case means for conducting spherical shell and hollow sphere. And for these three cases, the electric field E is zero inside any conducting sphere. So for in that case, the answer would be A, that is zero. But here it is a non-conducting sphere, so the answer will be 1 by 2 q over epsilon naught. Okay. Um, and inside it, if it is asking for the surface part, so surface part, okay, it is asking for the surface part. Now the surface part, yeah, the correct one is zero. The answer is zero. It is asking for the surface part. If it would ask for inside the sphere, so at that time the answer would be 1 by 2 q over epsilon naught, but it is asking for the flat surface now. So yeah, the correct answer is zero. That is option A. Now, next question 5. The electric potential Vx in a region around the origin is given by Vx equals to 4x square volts. The electric charge enclosed in a cube of 1 meter side with its center at the origin is, okay. So again, this question is from the chapter of electrostatic potential. Electrostatic potential, okay. So we are given with the potential, that is Vx equals to 4x square volt. And for this, we have to find the electric charge enclosed in the cube. So we know that E is equals to what? Minus del V over del X. So for this, this will become minus of 8x now. And we will have flux through the surface. Let me first draw it. Let us say this is a cube of side 1 meter, okay. So if we have to find the electric charge of this cube having 1 meter side with its center at the origin, means this is the center would be at the origin. So this will be 0 comma 0 comma 0. So for this, let us say this is surface 2, this one, and this is surface 1, okay. So for the flux through surface 1 and 2 only, because the center is at the origin, so we will have flux for this first and second surface only. So for that case, the total flux phi will be equals to, that is phi 1 plus phi 2, that is through the surface of first and second. So in that case, it would be equals to minus of 8 that is Vx into 1 by 2 into sorry, it would be plus phi 2 now, minus of 8 into minus of 1 by 2. So it would be equals to minus of 4 and minus of 4. Okay, so this will be equals to minus of 8. Since we know that flux phi is equals to E dot A, means EA cos theta. For dot product we always use cos theta na, and for cross product we use sin theta. So in case of dot product we use EA cos theta, and for here the area would be 1 square, means 1 only, and here also it would be 1 square, that is 1 only na. So for that case the correct answer is minus 8. Okay, so from the Gauss law, the total flux phi will be 1 over epsilon naught times the total charge enclosed by the surface. So it would be equals to, so at that time charge, sorry, we have to find the charge now. So Q will be equals to flux into epsilon naught. And in this case, the flux is minus 8. So it would be minus 8 into epsilon naught. So this is our final answer, that is minus 8 epsilon naught. So among these four, option A, 8, sorry, option D, minus of 8 epsilon naught is the correct answer. Now, next question 6. A heater coil is cut into two equal parts and only one part is now used in the heater. The heat generated will now be, okay. So in this question, we are asked to find the heat generated, whether it is 4 times double half of 1/4 times, okay. So we know that the formula for heat generated is heat generated. It is equals to H equals to V square into time over R resistance. And this heater coil is cut into two equal part and only one part is now used in the heater. So after cutting into equal lengths of heater, coil will become half 1 by 2. So at that time, this R is directly proportional to length. Okay. So resistance of the coil will become R equals to R by 2. R dash equals to R by 2. So at that time, the heat generated as dash which will be equals to V square T over now the resistance will become half of the previous one. Okay. So it would be R by 2. So this will be 2 of H means that of the previous one. H as R reduces to half. So H dash will be double. So the correct answer is option B. Now, moving towards our next question 7. In a region, steady and uniform electric and magnetic fields are present. These two fields are parallel to each other. A charged particle is released from rest in this region. The path of the particle will be okay. So we have to find the path of the particle. So since the charged particle will move along the lines of the electric field, okay, and whether it is an electric field or we consider it as a magnetic field. Okay, so the charged particle always move along the lines of the electric field or magnetic field. So magnetic field will exert no force. The force by the electric field will be along the line of the uniform electric field. Hence, the particle will move in a straight line. The force due to this magnetic field will be 0, and the only force is due to the electric field, and the force will be along the lines of the uniform electric field. Hence, it will move in a straight line. Okay, so the option B, that is a straight line, is the correct answer. Now, question number 8. An object is thrown vertically upwards at its maximum height. Which of the following quantity becomes 0? So we know that at maximum height, V is 0. So since M into V, since V is 0, so M into V automatically becomes 0. So for this momentum, P is equals to 0. So so the correct answer is option A, that is momentum will become 0. Okay. Now next question 9. The self-induced EMF of a coil is 25 volt. Okay. When the current in it is changed at uniform rate from 10 ampere to 25 ampere in 1 second, the change in the energy of the inductance is, okay. So we have to find the change in the energy of the inductance. So first of all, this question is from the chapter of electromagnetic induction. Electromagnetic induction. Okay, so to find the change in the energy of the induction, we will use the Faraday's law of electromagnetic induction. Faraday's law. So according to Faraday's law, we know that induced EMF E is equals to minus of del phi over del T, where phi is equals to what? B dot A. Okay, so and we know that L into di by dt, this will be equals to, according to question, it is given as 25 volt, na? So it will be 25. So it is equals to L into di by dt, means the current is changing from 10 ampere to 25 ampere, means the change in the current here is 15 ampere. So it will be 15 over time. Time is 1 second. 1. So from here we can find the inductance L is equals to 5 over 3 Henry. Let us say this is equation number 1. So the change in energy of the inductance delta E will be equals to what? 1 by 2 L I1 square minus I2 square. So it will be equals to 1 by 2. Here L is 5 by 3 Henry. I1 is square. I1 is 25 and I2 is 10. So 25 square minus 10 square. So simplifying it, we get delta E. Energy is equals to 5 over this 6 into this. This will become 525. So it will be 437.5 joule. Okay, this is the final answer. So the correct option is option B. That is 437.5 joule. Now next question 10. Alternating current cannot be measured by DC emitter because, okay, so this is from the chapter of alternating current itself. Okay, so so alternating current cannot be measured by DC ammeter because okay, so DC ammeter measures average value of the current. So in an AC current, that is in an alternating current, the average value of current in complete cycle will become 0. Hence the reading will be 0. Okay, so the correct answer is option A, that is average value for the complete cycle is 0. Okay. Yeah, the next question is 11. So the question says that the magnetic field of a plane electromagnetic wave is given by, and it is given as B equals to 2 into 10 to the power 8 sine 0.5 into 10 to the power 3x plus 1.5 into 10 to the power 11 t j cap Tesla. Okay, so we have to find the amplitude of the electric field would be, okay. So this question is from the chapter of electromagnetic wave. So we know the famous relation between electric field and the magnetic field, that is E is equals to BC. So if we want to find the electric field, so we have to multiply this B with the speed of light c. So here we are given with B equals to 2 into 10 to the power minus 8 sine 0.5 into 10 to the power 3 x plus 1.5 into 10 to the power 11 t j cap. Okay, so E will be equals to this B modulus of B into C. So it will be equals to this 3 into 10 to the power 8 into 2 into 10 to the power minus 8. Okay, so E will be equals to 3 to the 6 volt per meter. Okay, that is 6 volt per meter, and it is B dot C na. So the magnetic field is along the jth cap, means along the y axis. So the electric field will be along the x axis. Okay, since we know that, let us say this is x axis, this is y axis, and electric field magnitude is along the x axis, and magnetic field magnitude is along the y axis. So their wave will travel along the z direction. Okay, so if the magnetic field is along the y-axis, so electric field must travel along the x-axis. So the correct answer is option A, that is 6 volt per meter along the x-axis. Okay, now next question. Question number 12. An ideal gas is expanding such that PT cube equals to constant. The coefficient of volume expansion of the gas is, okay. So this question is from the chapter of kinetic theory of gases. Okay. So we are given PT cube equals to constant. Since we know that for an ideal equation, PV equals to nRT. For this is the ideal gas equation. Ideal gas equation. Okay, so in case of pt na, so we can write in place of p we can write nRT over v. So just put this value here, so we get nRT over v into t cube, it is equals to constant. Okay, so this will become t to the power 4 na. Yes, this will become t to the power 4 and this will become v inverse, so it will be equals to constant. So now take log on both sides. So taking log on both sides, we get 4 ln t minus 1 ln v. It is equals to ln constant. Now differentiating this equation with respect to time. So we get 4 del t over del t is equals to, this will be del v over capital V. Okay. So, and this is constant now, so it will become 0 obviously. So from here we get dv is equals to v into this 4 into delta t, or we can write dt, whatever we want. So from, let us say this is equation number 1 and this is equation number 2. Okay. Yeah, so from first and second, we get, sorry, this is gamma, I think. Since we know that del V by del T is equals to, del V by del T equals to V into gamma, na? Or we can say, this is what? Del V by V equals to gamma into delta T. Yeah, this one is correct. So in we can write here gamma del V equals to V gamma delta T. So from equation first and second, we find that gamma is equals to what? 4 over T. Del V over V equals to gamma. Yeah, gamma will be equals to 4 over T, na? So this is the correct answer. Gamma equals to 4 by T. So among these 4 options, C, that is 4 by T, is the correct answer. Okay. Now next question 13. Two light beams of intensities in the ratio 9:4 are allowed to interfere. The ratio of the intensity of maxima and minima will be. So this question is from the chapter of wave optics. Wave optics. Okay. So we know that the ratio of I maxima, we know that I maxima is equals to what? I1 plus I2 whole square, and I minima is what? I1 minus I2 whole square. Na? So this is, let us say, first and second. So dividing the first by second, so we get I max over I minimum. It will be equals to, uh, sorry, it is root I1 root I2 and it is root I1 and under root I2. So it will be under root of I1 plus under root of I2 whole square over under root of I1 minus under root of I2 whole square. Okay. So just put the values as given in the question. I1 is 9, I2 is 4 over under root of 9 minus under root of 4. Its whole square and its whole square. Okay. So just solving it, we get under root of 9 is what? 3, under root of 4 is 2, whole square, and under root of 9, 3, under root of 4 is 2, whole square. So 3 plus 2 is 5, 5 whole square is 25, 3 minus 2 is 1, 1. So it will be 25:1. Okay. So the correct answer is option 4, that is 25:1. Now next question 14. The de Broglie wavelength of proton and an alpha particle are equal. The ratio of their velocities is, okay. So this question is from the chapter of modern physics. we know that the de Broglie wavelength is equals to lambda equals to h over p, where h is the Planck's constant and p is the momentum of the particle. So we can write it as h over m into v. Okay. In the question, we are given that lambda of proton is equals to lambda of the alpha particle. So for lambda of proton, we can write h over mass of proton into velocity of proton, and it is equals to h over mass of alpha particle into velocity of alpha particle. Okay, since the h's are same, so they cancels out each other, so we get mass of proton into velocity of proton is equals to mass of alpha into velocity of alpha. And we know that the mass of alpha is equals to 4 times the mass of proton. Okay, so just put the value here and we'll get our desired answer, that is mass of proton into velocity of proton is equals to 4 mass of proton into velocity of alpha. So this mass of proton cancels out each other, so we get velocity of proton over velocity of alpha is equals to 4. That is the correct answer. That is option B, 4:1. Okay. Now, next question 15. The recoil speed of hydrogen atom after it in going from, okay, after it goes from n equals to 5 state to n equals to 1 state is, okay. So we know that momentum P is equals to what? Change in the energy over speed of light c. So, and momentum P is equals to mass into velocity. So mass into velocity is equals to delta E over C. And we have to find the recoil speed of the hydrogen. So V is equals to delta E over M into C. So delta E means change in the energy when it goes from n equals to fifth state to n equals to first state. Now, so we know that in case of hydrogen atom, the energy is given by minus 13.6 over n square electron volt. So delta E will be here. It is equals to 13.6 over 1 square, means for one is first state minus, and it will be minus of 13.6 over 5 square. Okay, this is a change in the energy. So here we write, okay, 13.6 over 1 square minus of minus 13.6 over 5 square into since it is an in electron volt, so converting this electron volt into joule, so multiply it by 1.6 into 10 to the power minus 19 coulomb, so it will become joule in, okay, in terms of joule, huh? So it will be 1.6 into 10 to the power minus 19 over this mass of the hydrogen atom is 1.6 into 10 to the power minus 27 into c is the speed of light, 3 into 10 to the power 8 meter per second. So solving it, we get V is equals to 13.06 into 1.6 into 10 to the power minus 19 over this 1.6 into 10 to the power minus 27 into 3 into 10 to the power 8. So after simplifying it, we get the recoil speed of hydrogen atom V is equals to 4.17 meter per second. So this is the final answer. Okay. So among these four option third, that is 4.17 meter per second is the correct answer. Now, next question 16. Which of the following figure represents the variation of log of R over R naught with log of A if R is the radius of a nucleus and A is the mass number? Okay, so this question is from the chapter of nuclei itself. So we have to find the correct graph. Okay. So we know that the radius is given as R equals to R naught A to the power 1 by 3 na, where R naught is the constant and its value is 1.5 Fermi. 1.5 Fermi means 1.5 into 10 to the power minus 15 meter, because 1 Fermi is equals to 10 to the power 15 meter. Okay. It is 10. So this is the famous relation for between radius and the mass number A, R equals to R naught A to the power 1 by 3. And its graph is something like this. And so if we take the log of this, so we can write it as R over R naught is equals to A to the power 1 by 3. Now taking log on both sides, so we can write it as log of R over R naught is equals to 1 by 3 log of A, mass number. Okay. So this comparing it with the equation of the straight line, that is y equals to mx plus c. So from here we get m means slope, m equals to 1 by 3 now. and c equals to 0. So for this, if we says that in x-axis we put log of a, and in y-axis if we put log of r over r naught, so this equation will look like this something. This is angle theta, and here the slope is m equals to 1 by 3, means so the slope is tan theta na, so tan theta equals to 1 by 3. So the graph will be very much like as shown in the figure b, that is log of r over r naught, this is log of a, and this is the straight line, because this equation resembles very much to the equation of the straight line, that is y equals to mx plus c. So among these four, option b is the correct answer. Okay. Now, question number 17. This question says that the Zener breakdown occurs in a PN junction having P and N both. Okay. So since it is dealing with the PN junction diode, so this question is from the chapter of semiconductor devices. Okay, and it is saying ki Zener breakdown occurs in a PN junction having P and N both. Okay, so we know that the Zener diode is heavily doped PN junction diode, so it has narrow depletion layer. Okay, so the correct option is B, heavily doped and the narrow depletion layer. Means like this is if P, this is an N, so this is the depletion layer. In a PN junction diode, this is the depletion layer, and this depletion layer is heavily doped, and the PN junction and the Zener breakdown means like this. If this graph resembles the Zener breakdown voltage, this one, so this, let us say this is point A, this is point B. If this represents the breakdown voltage, so this is very near to this depletion layer. So option B is the correct answer. Now, question number 18. If E and H represents the intensity of electric field and magnetizing field respectively, then the unit of E over H is, okay. So this question is from the chapter of electromagnetic induction, okay. Electromagnetic induction. So we have to find the unit of E over H. Okay, so first of all, we know that E is equals to V over L, and we know that B into L equals to mu naught into I. Okay, and so we know that H is equals to B over mu naught na. So from here we can write H is equals to I over L. So multiplying with mu naught on both the sides of it, we get mu naught H is equals to mu naught into L multiplying here. So it will be mu naught HL equals to mu naught I. So from these two equations, this is equation 1 and this is 2. So from first and second, E over H, we can say it will be equals to V into L over 1 cross I, that is equals to R. So E over H is equals to R, means it has a unit of R, resistance means ohm. Okay, so the correct answer is option A. Now next question 19. A stone of mass M tied to a string is being whirled in a vertical circle with a uniform speed, and the tension in the string is, okay. So let us try to understand it with the help of a graph. So let us say, if we take a journal point, let us say this is point P, okay. Let us say this is point P and this is angle theta. So in downward direction, we know that the force is mg. So, and here also it will be mg sine theta resolving into its component part. And this must be the tension force, that is mg cos theta. So if this is the angle theta, so this would be angle theta, okay. So, sorry, this will be the angle theta, not this one. This is angle theta, this must be the angle theta. So here will be the force mv square over r naught. Let us say this is the point P itself. So we know that the T plus mg cos theta from this will be equals to this mv square over r, or we r naught or r, just write it as r only. So mv square over r. So from here T will be equals to mv square over r minus of mg cos theta. So T will be minimum when this mg cos theta is maximum, or we can say when cos theta is maximum, okay? So cos theta will be maximum when theta will be equals to 0. So theta is 0 when string is at the highest point, okay? So the correct answer is option B, that is, it is minimum at the highest point of the circular path. Now, next question 20. A particle is moving with a velocity v equals to k y iota cap plus x j cap, where k is a constant. The general equation for its path is, so this question is from the chapter of kinematics. So we are given with the velocity v equals to k y iota cap plus x j cap. So we know that velocity is what? Dx over dt. So in place of v, just write dx over dt. It will be equals to what? K into dx over dt na. So it will be k into y, and dy by over dt will be equals to kx. So dy over dt over dx over dt will be equals to kx over ky, cancelling kk. So we get x over y. So dy dt cancels. So dy by dx, it will be equals to dy by dx. It will be equals to x over y basically. Okay. So this y into dy, it will be equals to x into dx. Now integrating this equation, both side we integrating this equation, so we get y square is equals to x square plus c. This is the final answer. Okay. So the correct answer is option C, that is y square equals to x square plus constant. So so this the option. So the next question is 21. A particle of mass m originally at rest is subjected to a force whose direction is constant but magnitude varies with time according to the relation F equals to F naught 1 minus T over T whole square, where F naught and T are constant. The force acts only for the time interval 2T. The velocity of the particle after time 2T is, okay. So this question is from the chapter of laws of motion. Laws of motion, okay. Now, according to the question, we are given force as F equals to F naught 1 minus T over capital T whole square, okay. Now we know that from the second laws of motion that F is equals to mass into acceleration. So from here we get acceleration equals to F over m, force over mass, okay. So A will be equals to 1 over m into F, that is F naught 1 minus T over capital T whole square, okay. So we know that acceleration is equals to del V over del T, means uh, rate of change of velocity with respect to time. So it will be equals to F naught over m 1 minus T over capital T whole square. Whether we write T minus T or T minus T, it is the power is whole square, means it will automatically becomes positive, okay. So A will be equals to limit from 0 to V dV. So it will be equals to F naught over M limit 0 to 2T, and it will be 1 minus T over T whole square, okay, and dt. Okay, so we have taken the force limit of force from 0 to 2t, since we are given that the force acts only for the time of interval 2t. So let us say the original time is 0, so the final time will be 2t, okay. That's why we have taken the limit from 0 to 2t, okay. So solving it, we get v is equals to f naught over m. Now for solving it, integrating 1t plus 1 over 3t square t minus t cube limit 0 to 2t, okay. This will become v is equals to f naught over m t plus 1 over 3t square. This will become 2t, 2 capital T 1 over 3t square t minus 2t cube by putting the limits from 0 to capital 2t minus 0 plus t cube over 3t square. Okay, so it will become v is equals to f naught over capital M 4t over 3. Okay, so this is our final answer, that is velocity v is equals to f naught over M 4t over t. So the correct answer is option 3 C. Okay. Now next question 22. The magnetic moment of an electron revolving in an orbit around nucleus with an orbital angular momentum is given by. Okay. So this question is from the chapter of modern physics. Okay. Modern physics. Now we all know that M is equals to magnetic moment, M is equals to current into area. So capital M magnetic moment is equals to current over area. Current is E over 2 pi R over V into area is what? Pi R square. Okay. Um, let the orbit is having a radius of r. Okay, and we have taken I like this since we know that current is what? Charge over time, and charge is E and time is what? 2 pi r over V na. So that's why we have written in place of I E over 2 pi r over V into pi r square. So this magnetic moment M will be equals to this pi cancels, 1 power of r cancels, so it we will get half e v r. Okay, so this will become M is equals to m v r over 1 into e by 2m. Okay, now M will be equals to e l over 2m, so M will be equals to minus of e l over 2m. Okay, so from here this M equals to e minus of el over 2m means M and L will be always in opposite direction. Okay, so from here the correct answer is mu L is equals to minus el by 2m means option B is the correct answer. Okay, now next question 23. Angular momentum of the particle rotating with a central force is constant due to. Okay, so this question is again from the chapter of laws of motion. First of all, since we know that torque tau is equals to what? dLc over dt, where this LC is the angular momentum about the center of mass of the body. Okay, so central forces act along the center of mass, therefore the torque about the center will be equals to 0. So tau equals to 0, it means this LC will be equals to constant, means this torque tau will be 0. So from the correct given options, the option D, that is 0 torque, is the correct answer. Okay, now next question. The escape velocity of a body depends upon mass as. Okay, so we know that the escape velocity formula V is equals to under root of 2gr, and uh, in terms of mass, so we write it as under root of 2 gm over capital R. So VE means escape velocity is directly proportional to 0th power of mass. Okay, so the correct answer is option A. Okay, now next question. Potential energy as a function of R is given by U is equals to A over R raised to the power 10 minus B over R raised to the power 5, where R is the interatomic distance, A and B are positive constant. The equilibrium distance between the two atoms will be. Okay, so this question is from the chapter of central forces. Okay, so in this question, we know that at equilibrium, whenever equilibrium conditions come, we know that at that time the force becomes 0. So for this, we can write minus of del U over del R is equals to 0. Since we are given U is equals to A R raised to the power 10 minus B over R raised to the power 5, and we know that force is equals to minus del U over del R. Okay, so putting its value equals to 0, so differentiating U with respect to R position, so we get 0 is equals to minus of del over del R of this A over R by 10 minus b over r by 5. Okay, so now differentiating it and putting it equals to 0, we get a over r raised to the power 11 into 10 minus 5b over r raised to the power 6 is equals to 0. So from here we get 1 over r raised to the power 6 equals to 10a over r raised to the power 5 minus 5b over 1 equals to 0. So this will become 10a over r raised to the power 5 is equals to 5b. So r raised to the power 5 is equals to 10a over 5b. So from here we get r is equals to 2a over b raised to the power 1 by 5. Okay, this is our final answer. So the correct answer is option C, that is 2a over b raised to the power 1 by 5. Okay, now next question 26. If two soap bubbles of different radii are connected by a tube, so we have to find the correct answer from these four options. Okay, so let us say the outside pressure be P naught. Okay, we are given with two soap bubbles. They are of different radii. Let us say this is R and this is R1. So we have to find the correct answer. Let us say the pressure outside be P naught, and let us say this is small r and this is capital R. Okay, so let us say small r and capital R be the radius of the, let us say this is small bubble and this is bigger bubble. Okay, so therefore, P1 pressure for the smaller bubble will be, this is for a smaller bubble, okay? P1 pressure will be P naught, that is of outside pressure, plus 2T over R, and P2 means for the bigger bubble, okay? For bigger bubble, it will be P naught plus 2T over capital R, where this capital R is greater than small r. Okay, so from these two conditions we find that P1 is greater than P2, hence air moves from smaller bubble to bigger bubble. Okay, so from this we can say that option A, that is air flows from the smaller bubble to the bigger bubble, is the correct answer. Now, next question. The focal length f is related to the radius of curvature r of the spherical convex mirror by. Okay, so this question is from the chapter of optics. Okay, and we know that for convex mirror, focus is behind the mirror. Okay, so its focal length f will be positive. F is equals to plus of r by 2, because for a convex mirror, spherical convex mirror, the focus is behind the mirror. Okay, so it will be always positive, so it will be plus of r by 2, means option A, that is f equals to plus r by 2, is the correct answer. Now next question 28. A thermodynamic system is taken from an original state D to an intermediate state E by the linear process shown in the figure. Its volume is then reduced to the original volume from E to F by an isobaric process. The total work done by the gas from D to E to F will be volume V in terms of meter cube is. Okay, so we have to find the correct answer. So first of all, this question is from the chapter of thermodynamics. Thermodynamics, okay. Now, work done by the gas will be equals to, we know that area under the curve, work done will be equals to area under the curve. Na? So work done by the gas from this D point to E point will be equals to, work done from D to E will be equals to area under the curve. And this is triangle. It means area will be half into base into height. Okay. So here in this case, it will be half 600 plus 300 into this 5 minus 2, 3 na. Okay, because area of triangle is what, half into base into height na, so it will be equals to half into base is, it will be equals to half into base is what, 5 minus 2, that is 3, into height is what, we have to find DE na, so its height will be this 600 plus this 300, so 600 plus 300, so it will be equals to 1 by 2 into 3 into 900. Okay, so it will be 450. So it will be equals to 5 3 15. Carry 1 4 3 12. 113. 1350 joule. Okay. Now the work done by the gas from E to F. From E to F will be equals to E to F. It will be equals to simply, this is in the decreasing direction. So minus of 300 into this 5 minus 2 3, so it will be equals to minus of 900 joule. Okay, so the total work done by the gas from D to F, then to F, D to E, then to F, it will be equals to WDEF. So it will be equals to summation of this first and second, so it will be equals to 1350 joule minus this 900 joule, so it will be equals to 450 joule. Okay, so this is the final answer, means option B is the correct answer, that is 450 joule. Now next question 29. A vertical electric field of magnitude 4.9 into 10 to the power 5 Newton per coulomb just prevents a water droplet of a mass of zero point 0.1 gram from falling. The value of charge on the droplet will be. Okay. So this question is from the chapter of electrostatics. Electrostatics. Okay. Now we know that as the droplet is at rest, so the net force will be equals to 0. Okay, so force will be mass into gravity, since it is falling na, so we have to just prevent it from falling. So this mass into gravity, downward force, will be equals to this charge into total electric field, so the charge will be equals to mg over E. So from here we get Q is equals to mass is what, 0.1 gram, means 10 to the power minus 3 kg, into gravity 9.8 over E. E is given as 4.9 into 10 to the power 5. Okay, so solving it we get Q is equals to 2 into 10 to the power minus 9 coulomb. Okay, so the correct answer is option B, that is 2 into 10 to the power minus 9 coulomb. Now next question. In the circuit shown in the figure, the total charge is 750 microcoulomb and the voltage across capacitor C2 is 20 volt. Then the charge on the capacitor C2 is. Okay. So this question is from the chapter of electrostatic potential and capacitance. Electrostatic potential and capacitance. Okay. Now in this figure, we are given with uh, total charge is 750 microcoulomb. Q is equals to 750 microcoulomb, means Q1 plus this, let us say this is Q1, this is Q2 and Q3. Okay, let us say Q1, Q2 and Q3. So 750 microcoulomb. Okay, so and the voltage across capacitor C2 is 20 volt. C2 C2, around C2 it is 20 volt now, and this is charge, Q is flowing through it. Okay, so Q will be equals to Q2 plus Q3. Okay, capacitors C2 and C3 are in parallel. Okay, so voltage across C2 will be equals to voltage across C3, since both are parallel. Okay, so C2 voltage across C2 will be equals to voltage across C3, so it means it is equals to 20 volt. Okay, so the uh, charge in the capacitor C3 will be equals to Q3 will be equals to, since we know that for capacitances Q is equals to C into V. So Q3 will be equals to C3 into V3. Since C3 is what? 8 microfarad into V3 is what? V3, it is 20 na, since C2 and C3 capacitances are in parallel. So if these are in parallel, they will have same voltages. So it means C3 is also having 20 volt. So Q3 is equals to 8 into 20. So it will be equals to 160 microcoulomb. And for Q2, it will be equals to 750 microcoulomb overall, since Q2 plus Q3 equals to capital Q na, and capital Q is 750 microcoulomb. So Q2 will be equals to this 750 microcoulomb minus Q3. Minus Q3 means 160 microcoulomb. Okay, so it will become 590 microcoulomb. This is the final answer, means the correct option is B. Now next question 31. For a transistor, alpha and beta are given as alpha equals to IC over IE and beta is given as IC over IB. Then the correct relation between alpha and beta will be, okay. So we know that for a common emitter transistor, we know that IE means current through the ammeter is equals to current through capacitor plus current through base. And we know that alpha is what? IC over IE as given in the question, and beta is given as IC over IB. Okay. So we have to find the correct relations among these four. So from here, IC over alpha will be equals to what? IE plus IC over beta, using the relation that is IE equals to IC plus IB na. So if we write it as IC from here, so IC over alpha will be equals to IE na, and from here IC over beta, IC over beta will be equals to what? IB. So just IC plus IB plus IE na. So that's why we have written IC over alpha equals to IE plus IC over beta. So from here we can write, okay, so from here we can write it as 1 plus 1 over beta is equals to 1 over alpha. This implies that 1 over beta is equals to 1 minus alpha over alpha. That is beta is equals to nothing, alpha over 1 minus alpha. Okay, so this is the final answer. That is beta is equals to alpha over 1 minus alpha, means option B is the correct answer. Okay. Now, heading towards next question 32. A current I flows along the length of an infinitely long, straight, and thin wall pipe. Then, okay, we have to find the correct answer among these four options. So, this question is from the chapter of the alternating current. Alternating current, okay. Yeah, so now we know that there is no current inside the pipe, since it is a long infinity straight wire na, and um current I flows to along the length. Okay, the current is flowing along the length. Along the length mean if we are talking inside the pipe, so inside the pipe there is no current. Current I is equals to 0, and we know that from Ampere's circuital law, integration of B dot dl is equals to mu naught into I. Since I is 0, so B will be equals to 0. So from this, the option D, that is the magnetic field at any point inside the pipe, is 0. We are not talking about the outside the surface of the pipe. We are dealing with the point that is inside the pipe. So for inside the pipe, the magnetic field will be 0. Okay, since the current is flowing along the length of the infinitely long wire. Now the next question 33. A Carnot engine has efficiency of 50%. If the temperature of the sink is reduced by 40%, its efficiency increases by 30%. The temperature of the source will be, okay. So this question is from the chapter of thermodynamics. First of all, we have to understand what is Carnot's engine. Okay. So if what happens in a Carnot engine, let us say this is the source. Okay, there is a source and this is sink, and between the source and the sink there is a heat engine. Okay, heat engine. Let us say the temperature of the source is T1 and the temperature of the sink is T2. So always remember, champs, that the temperature of the source is always greater than the that of that sink. So if Q1 is the heat that is transferred from source to heat engine, and Q2 is the heat that is transferred from heat engine to sink, so we can write a term that is eta. Eta is called the efficiency, and it is equals to 1 minus Q2 over Q1. That is the heat that is transferred from heat engine to sink and the heat that is transferred from source to heat engine. And there is another formula for calculating this efficiency eta, that is eta is equals to 1 minus T2 over T1, as we know that this Q2 over Q1 is equals to T2 over T1. Okay, so using these relation we will find the answer of our question. So in this question we are given the efficiency of 50%. Okay, and if the temperature of the sink is reduced by 40%, 40 degrees Celsius, then its efficiency increases by 30%. So we have to find this T1, that is the temperature of the source. Okay, let us write this as okay, so eta efficiency is given as 50%. Now 50% means it is 50 over 100, that is 1 by 2. So from here we can write 1 by 2 is equals to 1 minus what T2 over T1 means that of the sink and that of the source. Okay, so when eta increases by 30% means 1 by 2 into 1.3, it will be equals to 1. It when it is increases by 30%, the temperature of the sink is reduced by 40%. Now, so we can write it as 1 minus T2 minus 40 over T1. T1 is that of the source, and we have to find this T1 only. Okay, so from here we can write 1 by 2 into 1.3 is equals to 1 by 2 plus 40 over this T1. So from here we get T1 is equals to 266.7 Kelvin. We have converted this 40 degrees Celsius in terms of the Kelvin, that is a standard scale. So the correct answer for this is option C, that is 266.7 Kelvin. Okay. Now next question 34. When you walk through a metal detector carrying a metal object in your pocket, it raises an alarm. This phenomena works on, okay. So whenever a metal detector works on the principle of transmitting an electromagnetic signal and analysis a written signal from the target, so it works on the principle of resonances in AC circuit. So the correct answer is option B, that is resonance in AC circuit. Okay, now next question 35. An electron moving with the speed v and what is this? I don't know. Maybe it is photon, sorry, not proton. Okay. An electron is moving with the speed v and a photon with the speed c, having same de Broglie wavelength. The ratio of kinetic energy to electron to that of the photon is, okay. So this question is from the chapter of modern physics only. Okay. So as we know that the de Broglie wavelength lambda is equals to h over p, where h is the Planck's constant and p is the momentum of that particle. So let us say lambda E is the wavelength of the electron and lambda P will be the wavelength of the photon. So from here we can write, okay, since they are moving with the same de Broglie wavelength, so lambda E will be equals to lambda P. Okay, using this condition we can write H over PE will be equals to H over PP, means that of the photon. Okay, so since H is the Planck's constant, so they will be same for both the substances, that is for electron as well as for the photon. And we know that the momentum P is equals to under root of 2m into kinetic energy. It will be equals to energy of photon over the speed of light. So from here we can write this HS cancels. So PP will be equals to PE. So from here we can write 2mke, means squaring both sides. We get 2mke is equals to energy of photon whole square over c square. So just write it as 2mke is equals to EP square over c square. EP square over c square. Na? So kinetic energy over energy of photon will be equals to energy of photon over c square into 1 over 2m. Okay. So from here we can write this momentum of photon over c, this will be equals to momentum of photon over c into 1 by 2m, since energy of photon is equals to momentum into speed of light. Na? So from here we have written this, in place of energy we have written momentum of photon. Okay, so it will be equals to this energy sorry, momentum of electron over c into 1 by 2m, since we know that the momentum of photon is equals to momentum of electron. Okay, so from here we write mv over c into 1 by 2m, so it will be equals to mm cancels out each other, so we can write it as v over 2c. So the ratio of the kinetic energies of the electron and that of the photon is v by 2c. That is option C is the correct answer. Okay.